Hey everyone, today we're going to solve another problem, that is LeetCode 2405, optimal partition of string. It's a very decent problem, although um, I will say that this problem is little tricky to understand because of the some of the words like substrings and unique. I mean, for me, I have wasted 5 minutes on this problem. I did not quite get the concept, but after looking at the test cases, and then I understood the problem. And it's a very decent problem, as you can see, 1.8k likes and only 73 dislikes. That's a very good ratio. And yeah, so let's start this problem. So we are given a string s, and we need to partition the string into one or more substrings such that the character in each substring are unique, right? So that is, no letter appears in a single substring more than once. Return the minimum number of substrings in such a partition. Okay, this is important. We need to return the minimum number of substrings in a partition. Note that each character should belong to exactly one substring in a partition. So what this problem is saying, for example, we are given this string that is A, B, A, B, A, C, A, B, A, right? Now we need to partition it in such a way that we have minimum number of substrings, and those substrings have a condition that there should not be any repeating character. So for example, if I partition it in such a way that a is fine, right? B is fine. So this is one partition, A and B, and then this whole string. This string can be partitioned again, but I will tell you why I'm not doing it. Then I have A, C, A cannot be taken, right? Because there will be an repeating character. So this is the partition, another partition, and then you have A, B, and this is the one partition. Why? Because you find A and the A was there as well. So these are the partitions. So 1, 2, 3, and 4. Four partitions that we can find. Let's try another partitioning technique. So now you have this string. Now you will be partitioning this part, right? A, yes, it's fine. A and B, A, C, A, B, A. This is another string. These two substrings, and the string on this side, it doesn't have any repeating character. Yes. B also doesn't have any repeating character. Yes. Now you must be thinking that I can do this as well. Like each character is a substring, right? And it is a substring, and there is no repeating character. No. But this concept that we need to return the minimum number of substrings will be violated. By Because in this case you will be returning 7 substrings, but this is the minimum one. So in order to observe a pattern here, as you can see, if you want to return the minimum number of substrings, right, the number of substrings has to be minimum. For that purpose, you need to understand that the partitioning has to be done at the places where you have to stop partitioning. For example, the every substring has to be of the maximum length. So for example, in this case, this is the length AB, right? And but it can be partitioned in this way as well, right? But you are not doing it. Why? Because we need minimum number of substrings, and for that minimum number of substrings you need to make sure that every substring is of the maximum length, until and unless you encounter another character that will violate the unique substring condition, which means that this A cannot be taken for this string AB. Why? Because A is already present in the substring AB, and simple for this case. So that is how we'll solve this question, and I hope you understand the concept. Now let's try to code it out. So at first I'll be using an unordered set, and you can use a vector as well, but I'll be using an unordered set. I think I'm more comfortable with it. Then the answer is initialized with 1, and I'll tell you why it's initialized with 1. I is equal to 0, I is less than s dot size. We are iterating over the string, right? And there's this condition that if this s has to be set. So let it be set. Now set dot find, I'm finding in this set this character. Is there any character in this set? And if it is pointing to the end pointer, then it means that there is no character. Otherwise there is a character, and the previous substring that we already have registered in the set is our answer. So So that will be answer plus plus, which means that we have find a substring, and the set that, and the substring that we have already registered has to be cleared. And then we are going to insert the new character nonetheless. So 5. And then we'll return answer. Now you must be wondering why we are why we are initializing this answer to be 1, because it's given in the constraint that string length can be minimum 1. So for example, in this case where you only have 1, right? You don't have anything in the set size. You don't have anything in the set, and this condition will not run because set is all empty, and the first element will be the unique element, and you will be just inserting that element into the set. And this expression is never true, so which is why answer is never incremented. And if it is 0, then we are going to return 0 for this test case where you only have one character in a string. But in order to not fall into that trap, we need to initialize it to 1. And yeah, so I think that is good. Let's see if this will run. Okay, test cases are running fine. And it is getting accepted, and it's all right. Obviously it's not idealistically good, but it's all right. Just to give you a dry run of this algorithm, so what we are doing is, let's say we have this set, right? We have this set with us, and this is the set or the unordered set that I was using. This is the set data structure. Now what I do is I start from this element A, okay, and I store it here, okay. Then I start with B and I store it here, and then I encounter A, then I'm at this A. But now I realize that we already have this A, right? Which means that we have this incoming character is already in the set. So I will say that my substrings AB is one of the substring and it has the maximum length, and it is true. So which is why AB is one of the substring that I have counted, right? Then I will, because I have registered it already, and obviously we don't have to store the substring, we'll be just incrementing our variable where we are keeping the count of the substring. But we can erase this AB, this AB from our set. Why? Because this substring is registered, this substring is counted. Now this A has to be registered, okay? Now we move to the another element, and that is C. And this C will be registered again. And then we are going for A. Well, A is already present, so there's a problem. This A will not be registered now, and we'll say that this string that is AC is another substring. And we'll clear this out because we have already registered it. And then this A has to be inserted into the set. Now we move to the another element, that is B. Okay, we have B. And again, this string, now we move to another element, and that is A. A is already there, so we are not going to have A directly, but we are going to first store this substring or increment the substring variable, and then we are going to clear it out, and we'll say that this A is also in the set. Now you must be wondering that we are not registering it. No, we are actually, because we have answer variable is equal to 1, so it will take care of two cases. The one is where you only have where s is only equal to one character, and in every string where s is equal to a, b, or whatever characters, the last substring like this one, a, or it can be ab, will also be accounted if you will initialize your answer with 1. So that is the reason. Now talking about the time complexity, because we are iterating on each character of the string, and if the string length is n, so it will be order of n. And space complexity in theoretical point it will be 26, so it's nothing but equal to constant space, because the unordered set that we are using is the only linear data structure, and there obviously we have lowercase English letters, so it won't be more than a constant size, which is 26 or maybe 128 even if we have uppercase, but I think we are only given lowercase letters. Yeah, lowercase letters only. So that's order of 26 and it's a constant space. So yeah, this is the problem, and I hope it made some concepts clear to you regarding this problem. And if you have any questions, you can check the source code in the description. You can try this problem yourself. The link will be in the description. And if you still have any doubts, you can contact me on LinkedIn, or you can comment down below your doubts. Thanks for watching and have a good day.